Good evening, everybody. Thank you for coming. So today's my talk is about NSQ.io, which is a distributed messaging system I've been using for a few months in the project I'm working at the moment. I'll just put some words of warning. I haven't used any other messaging system in the past, so please don't ask me how does this compare to, you know, ZeroMQ, Kafka, whatever, because I don't know those things. So please bear that in mind. I know from what I've used on this one, and the little I've known from the other things is, like, if I wanted to just use them, how would I start them? And that's one of the things that you'll see about NSQ is really easy to get started with. And if you do your applications in a way that's decoupled from whatever messaging system you have, you can, you know, start with NSQ, do simple things, and then maybe move on to other queues that fit your purpose in a better way. Anyway, just a quick presentation about myself. So I'm a software developer. I work with a company called OpenJaw Technologies in Dublin. We develop travel technology software. The stack I've been using in the project there is mainly Node, NSQ, Angular, and then we have a variety of SQL and NoSQL backends. Then I've been dipping my toes into a little bit of DevOps world in doing a bit of service discovery with etcd, application deployment with Docker in the cloud. We're using AWS at the moment, and we also have a continuous integration pipeline with Jenkins. I'm also a photographer, so if you ever need any photography, please contact me. And I'm from Lisbon, Portugal. So this is the agenda. So we're just going to talk a little bit about queues, why you want to use them. Then we're going to go on to NSQ specifically, have a quick demo, and a Q&A at the end. So what's a queue? Well, as most of us know from our daily lives, you just go on to the supermarket, you have to queue, you have to wait. There's also another definition of queue, which is a list of data items, commands stored to be retrieved in a definite order, usually order of insertion. And it's also apparently, which I didn't know until I did this slide, something you do in the back of your hair, usually girls, or if you're a Viking or something like that. Anyway, so the one we're going to talk about today is the second one. So queues normally are a unified system where you can write data and read data. They do a lot of abstraction in terms of what the protocol is. You don't have to be tied to HTTP or SOAP. So you just choose your underlying data. So you might send in one message, you might send JSON, another message you might send message pack or binary data. It doesn't really matter what you do. It's up to you then to make it work for your system. It's also very well adopted in distributed architectures because you don't have to make calls from one process in one server to another in another server. And when things start to scale out, the complexity just becomes unbearable for most situations. So a lot of big companies you see out there, they use message queues for this. The other really nice thing that message queues have and give you is that you can either work real time, so your producers and your consumers are all up and they communicate seamlessly, but you can also work in a batch or offline mode, so you just write to the queue. You don't have any consumer. The queue does all the persistence or keeps it in memory. It's up to your own use case. But then the consumer comes in, or many consumers come up and they start consuming those matches. So I remember probably in the first years I was programming, we were doing this with SQL tables. It's the same concept. You write records into a table and then you mark them as processed, not processed, and you have a queue. So it's kind of the same thing, but they're just a bit more evolved these days. And then the other thing I kind of feel really interested in message queues is that if you wanted to change your application, sorry, I just let MS Code. If you wanted to change your application to do a different thing at some point, or maybe on some days do a different thing and other days not do some process, it's easy to do this with publish subscribe patterns we'll see later, or other patterns, without changing the code. So if you wanted to say have some logging system that's saving your logs to some sync, and now you want to start testing with a different log system, which is the latest and greatest, you could just go and plug into the message queue, subscribe to the same topic, and here you have your messages. And when I started programming, and probably still a lot of times I still do that, I would write my logging code into my code, so it's in the middle of the code. So tomorrow I want to change from whatever, log4net or log4j or Boolean or whatever if you're using Node, to something else, and I have to change my code. So it's kind of sucks a little bit. Or you have to write a lot of abstractions, which makes things more complicated and takes longer to deliver, which is always a problem, as you know. So there's kind of three common patterns for using queues. One is the unicast, where you have one producer and one consumer. It's kind of straightforward, so you just put in a message there, just one guy takes it out. There's no copies of the message delivered to anybody else. Then you have broadcast, which is kind of known as PubSub, where you produce a message, there's a bunch of consumers who subscribe to that topic, and they get that message, they all get that message. And there's another one called multicast, where you have a producer and several bunches of groups of consumers. And a message that is produced goes to all these groups, but only one consumer in each group will receive the message. So this is the thing that I really like, and it's really easy to do with NSQ. And that will allow you to do, for example, those kind of plug-and-play workflows where you start to create multiple groups. So you might have a group where you're doing logging, so you might have several consumers for logs, but only one receives the message, so you don't say the same thing twice. As if you were using PubSub, traditional PubSub, all of them would write, so you'd have a lot of redundant data, or a lot of actions that you'd have to program to be idempotent if you're changing anything. So, as I said, this is the one I really like, and I think NSQ gives you really easy way to accomplish. So NSQ has been around for, I believe, a couple of years. Not exactly sure when it started. I know it's a spin-off from a project, I believe it was called SimpleQ, which was just an HTTP kind of pattern. And then Bitly developed this new system, new SimpleQ. I don't know what's exactly. I think nobody knows exactly what NSQ means anyway. But this is where you can find the source code, their community, and their social media. There's a few names out here. My company is not here actually. We haven't gone in production yet, so we can't claim to have it in production. But it's interesting. I know, for example, that yellow one there, Halo, they're a company from London who also operate in Dublin. They're a taxi calling service. So you just open your application in your mobile and call me a taxi, and you have a taxi in 2 minutes, and you can see the little taxi on the screen. So I can imagine a lot of stuff they use. They might be using NSQ for that. I'm not exactly sure. Following on. So NSQ, the definition, at least from the site, it's a real-time distributed messaging platform that's designed to operate at scale, can handle billions of messages a day, is distributed, allows for distributed and decentralized topologies, has no single point of failure, has fault tolerance, high availability, and has a reliable message delivery guarantee. Now, if you want to read more about guarantees, because I think that's probably one of the first things you might want to look in the messaging system, you'll probably go to their site and you'll read all the the fine print there. The kind of the most important thing is that messages are guaranteed to be delivered at least to one consumer, but the order is not guaranteed. So that means if order is important for you, you have to account for that in your code. And there's also another, not a guarantee, but a kind of a sideline that a message might be delivered twice. So if there was a timeout on a consumer before saying, the message is processed, NSQ might try and send the message twice, so you might have to account for any deduplication or make your code be idempotent. In terms of libraries and tooling, so they support pretty much all the main languages normal companies use, and they have official libraries for Go and Python. There's a really well maintained package called NSQ.js for Node, and because this is a Node meetup, it's kind of what I'll show. The topic with the problem with this distributed systems usually is the service discovery. And this is just where I'll just talk about other projects. So when I was looking at using a different message queue called Kafka, Kafka depended on another project called Zookeeper to do leader election, and that's fine. And but you have to read two projects. They're maintained in separation. You kind of don't want this in my view. So they provide you with a daemon called NSQ lookup, which will organize all the topics, knows about all the consumers, all the producers. So when a consumer comes up and I say, "Oh, I want to know about this topic," he calls home to NSQ lookup, and NSQ lookup tells, "Hey, there's all these producers for that topic," and then he establishes a permanent TCP connection with that with those daemons. Then there's the NSQ daemon itself, which is used for publishing and subscribing to messages, and then there's a half a dozen NSQ shell utilities, which we'll look at later. So when you try and use other systems, a lot of times you have dependencies on JVMs, whatever VM kind of thing, put your own stack there. With NSQ, because it's written in Go, you get binaries. So you get binaries for Mac, you get binaries for Linux. There's no official distribution of Windows binaries, but if you go and see their GitHub issues, there are some guys that have compiled the project to Windows, and there was a few kind of issues at the beginning, but it seems to be mostly ironed out. I'm not exactly sure what's the state with the Windows, but it seems to be relatively well supported. So when you download, you get all these binaries, and if you look, it's not. I mean, it's probably around, I don't know, how much is that? 600. 60 something. The ones with the underscores are all those shell utilities. Then there's the other three: NSQ admin, NSQ daemon, and NSQ lookup daemon. So this is the tooling you get out of the box from the project. So you don't need to write your own thing that would just do, I just need to do this really basic thing. Those guys have thought of pretty much all the common use cases, because I believe they use this at Bitly, so they give us these binaries for free. So we'll go into those later. So if you wanted to start NSQ, you just locally to try on your machine, you could just do this two commands. So NSQ lookup D will start. You probably want to put that into some log, put it in the background, and then you start your daemon and you tell the daemon, here's the TCP address of the lookup D. The lookup D and the daemon, when they start, if you use the defaults, they both have two ports you can access. One for TCP connections and one for HTTP connections. So this allows you, for example, to do a curl into the HTTP address of the NSQ daemon and publish a message. So everything that your libraries have that can issue an HTTP request, you can plug into this message queue. So you don't even need an official client library if you don't have one. Maybe you're using some sort of small device, Internet of Things kind of project. And then you can also use a TCP connection. So that's what the libraries, most of them use TCP connection. Then if you're writing a program in Node, this just a simple subscriber program. So there's the NSQ.js module. You start your reader. You give it the list of HTTP, the lookup daemons. So it can be several or just one, at least one. You don't need to give it one. You could also, I believe, connect directly to a daemon if you knew the address. But because when you start scale out, you're going to have many daemons, and they might, die at some point because the machine went down or something. You really want to take advantage of their discovery system. So then you do your connection, and then you subscribe to this event, the message event, and that's it. When you are given a message, then you should issue a finish that will tell the daemon that this message is processed, and then it won't be delivered to anybody else. If you don't do this, the message will go into a timeout state. It will try to be published again, so it kind of probably go into some weird loops. And this is a simple program to write a message to an NSQ topic. So the same story. You do publish into a topic. So just in the middle there, you choose the topic, and then you send the message, and you close your writer if you want, or you can keep it open if you want to write more. This library allows you to send multiple messages. So where you have their message, it could be an array, so you could send multiple message to this topic. One of the actually kind of just going a little back to comparison to other message queues, at least I know some of them you have to create topics beforehand or using some kind of admin tool. With NSQ, topics are created on by request on demand. So when you publish to a message to a topic that doesn't exist, it's created, it's announced on the discovery system. So typically your NSQ daemon, you can start consumer on a topic that doesn't exist yet, and it will stay there, pulling for that topic, pulling the discovery system. When some producer comes in, then the discovery system will know, and then the consumer on the next pull will be told what's the IP and the port to go to consume those messages. So messages are sent on a push model, by the way, they're not on a pull. So this is the kind of a presentation on those shell utilities, and I kind of really like that you have this out of the box. It probably helps you a lot with debugging, but it might also put you up to speed in adoption of message, in this case of a message bus system like NSQ in your company. Let's say you have some weird legacy program that writes to standard out, and you want to put that on some topic. So you can, for example, use the first one. The first example there is just reading from standard in stream. So it's called to NSQ, and you just have to tell it the address of one of the daemons and the topic that you want to send in. So I just called it standard in. It could be whatever you wanted. The default for this is the delimiter is just the new line, but you could change it. So if you wanted to have some kind of logic, different logic, so you just start reading your standard in. You could, for example, read a file line by line, send it all to a topic if you had some kind of log file you wanted to process. Then there's the other one, NSQ to HTTP. So I think the name is self-explanatory. So you subscribe to a topic, and then whenever there's a message on that topic, you can send this into an HTTP as an HTTP request, either GET or POST. Then there's the NSQ tail, so this would be more of a kind of operations teams or debugging, where you can just see on your shell session all the messages. If you wanted to write things, let's say you have this whatever ordering system and you're processing orders, you could have this NSQ2 file, subscribe to the same topic, and write everything to a file. So if your system died, you have a history of all the messages, all the orders that were put through. So then what you could do after that, you could use the first one if you wanted to replay the whole thing again. So you could then read your log file, for example, and then try. It's also interesting in this, for example, if you have say a web server and you want to replay all these requests, you could have your web server send a message to a topic that would give you all the information you need to recreate a request. So then you could give this to some users. They could do all their experimentation, and then you could replay that. I mean, there's better tools out there to do that, but you could probably do your own logic if you wanted. Then there's a kind of a cross-data center or availability zone utility called NSQ to NSQ, which just does that, subscribe to a topic on this kind of NSQ ring and then sends it off to a different daemon. Normally you'd want to do this for cross-data center application, but you might also want to have like your NSQ ring that handles your business logic, all your requests, your application, and then you might want to have say analytics messaging kind of on the side so they don't interfere with one another. So let's go to the demo, and you're going to be amazed how stupid this demo is. Sorry?
Can you just activate the screen recording on QuickTime so I can have it?
Oh, okay. Yeah. Okay, so I'm just gonna try and make the fonts a little bit bigger. Is it any better for the people in the back of the room? I'm just going to go through. So on the first one here, I'm just going to actually I'll start with this one. So this is the one that uses the 2 NSQ. So I'm just going to read from the standard in. So whatever I type here and I hit enter, a new message will be put on this standard in topic. Then I have, for example, NSQ tail running here on that topic. So I'm just going to run that guy. So now if I come here and I put in some message there, it should show on the bottom one, and that's working fine. Then I could also have this one running that would save into a file. This is actually interesting. It has a kind of a good what you kind of expect from this kind of utility. It can do rolling of the file. It can do compression. You have some flags on the command line that you can use to change the way the file names are created. By default, it uses the topic name and something else I can't remember. You can also choose the output directory, so I'm just going to drop it into the same here. And then what I have here is just a Node application. So it's just an Express web server. And I have a NSQ integrated. So what I'm doing here is whenever something posts into my web server into this standard in route. I just send back a 200. I just write to the console just to see what's coming, and then I do a write onto a different topic. So that's kind of something you could do. You receive a request, and then you might want to put this on a different topic, say for maybe a metrics engine or analytics or auditing system, and that's just the boilerplate express. So if I start this now, what's happening here is I'm writing on the standard in on the first word there, and then the second, which I haven't started yet, is the NSQ to HTTP. So what it's going to do is it's going to consume the standard in topic. Whenever a message comes in, there's a post to my Express server standard in route, and then the Express server will write to an Express topic, just for the crack. So as you can see, this message was automatically there, so it was on the queue, waiting to be processed. So do I have everything running at the moment? No. So I'm just going to start an NSQ tail, which is the one that just does like a normal tail on the Express topic, and I'm not doing anything here, but I suppose I could do something here, like I don't know. It's the fun of demos. Hope it works. So if I put something there, it's gone through all the plumbing and ended up in the tail. So I have my highly complex business logic of changing this request into something else on the other topic. So that's kind of the demo I had, and I think it shows how you can easily. I just have this isolated here, so it's easier for you to see. It's kind of what's on the slide anyway. How easy it is to just use this and put it into a small kind of separate module that you can then use simply on your web server. So I'm just requiring my own, and then I just do the write. So I'm not introducing the dependencies, a lot of dependencies here. So I think it's an easy system to use. It doesn't tie you into weird languages that you don't know. At least for me, I can say that. So like Java, I never learned Java, so whenever this thing is Java, okay. And the only thing I've used for Java is that I kind of like is Jenkins, so I'm sticking just with Jenkins for now. The other thing that you get, I haven't shown yet, is the NSQ admin. So let's start one of those guys. Just to make it bigger. How big can you go? NSQ admin. So if I go here to where's the other guy running? Oh, actually I didn't. So actually, sorry, I forgot to show you something which is probably, it's important, but yeah, I've already shown it on the slide. So if you wanted to start, where was it? So I had already run these two commands earlier. So both the discovery daemon and the writer-reader daemon were already running. So sorry, I forgot to show that. So if I want to connect to there's another tool called NSQ admin, which you'll see in a second, and this is the same logic. So you have to tell it what the NSQ daemon directly is, or the lookup. So I'll just go for the lookup directly. And it's running on port 4161. So see, this admin guy wants to use the HTTP API of the daemon. So I'm connecting to the HTTP port. The convention is they have on their defaults is the 4160 for TCP, 4161 for HTTP, and then for the daemons 4150 for TCP, 4151 for HTTP. So now if I start this, there's my firewall just saying there, and now I have a web application running on this port. So if I try to open that, (4171), this is the NSQ built-in panel. So I think just this by itself is really good. You don't probably get a lot of tooling like this from other projects. You might get from other people who felt they needed this and built their own, but they might be detached. So here are the two topics that we created, the Express and the standard in. You have a little counter here, so you can see all the messages that went through. This is 74 because, as I said, I had already started those daemons before when I was testing this, preparing for the talk. So if you restarted the whole thing, you'd see starting from 0. So there's a few things you can do here. You're allowed to create topics on the fly if you want it. You have the stream, so you have the nodes. So this is just my machine, but you would see all the names of the machines that have daemons running, which ports they're running on, because you could choose your own ports, and how many lookup keys they're connected to, and how many topics. Then, if you go into one of the streams, for example, let's say the standard in. There's a few things that you can do here which are very useful. So you could pause the topic, for example. Let's say you have something that's putting a lot of pressure on your system, and you're not handling that because you don't have the capacity at the moment. So you might just pause it. And those daemons on the back burner, they'll have to do their thing. So if they have some watermark to persist to disk, they'll just do that. Then you can empty the queue, you can delete the topic, kind of operational stuff you can do. So in terms of the channels, I haven't really shown this in my slides, and I'll show you what channels are now in a second, but they're pretty much the idea of the consumer groups. So I'm looking at the standard in topic, and then the topic can have many channels, and every message is sent to each channel independently. On a channel you might have several consumers, and only one of them will get that message. So you'll see here, this is created automatically by the NSQ tail, for example, this last one here. NSQ to HTTP, NSQ to file. So all those little utilities that I started that connected to the standard in topic created their own channel, right? Then I didn't do any subscriber to this thing on my own. But if I had, I would have been given the option to choose the channel name I wanted. And then you can see a lot of statistics that go on, how many messages might be being processed, how many have been requeued, timed out, how many messages went to each one of them, how many connections. Here you can see something kind of slightly different from the other ones, this ephemeral. So ephemeral means that when there's no consumers or producers on this, when there's nobody on this channel, no connections on this channel, will be deleted. It also means that the producers who would write to this channel, they'll just let those messages go when they hit the watermark. So kind of going into watermarks, the way NSQ is designed to work is mostly an in-memory queue, but you have knobs you can use to configure it to do differently. So there's a parameter you can define how many messages you want to keep in memory, and above that number it will be persisted to disk. So that's kind of, I think, the most important setting. And from the usage I've been having with NSQ, which is not the main focus of the project I'm working on, we haven't had change a lot of those defaults. So I could say that at least for our use case, the defaults are very same. And apart from the first few days we were using this, we didn't have we haven't had any problems with NSQ whatsoever. How long have I started now? I kind of lost track of time. Not sure. Am I? Yeah. So if you want to see, I actually asked permission for Matt Raferson to show his presentation. So Matt is one of the owners of this project. I don't know him personally, but I asked him to show some of his slides, which I could probably have tried to do on my own, but I think his slides are really good. So this kind of highlights those patterns. So here you have a producer, you have a publish, subscribe, and 2 consumers. So your message just goes in, then it's sent to both of them. Then you have the distribution, where a message goes to one, and then the other goes to the other one. Then you'd have your failure modes, where messages go, and then a consumer is taken off, or maybe there's a network partition, and messages just go to the other one. Or you might have a complete consumer, all the consumers fail, and then message will start to be persisted to some kind of store. And then when a consumer comes up, it starts consuming the messages that were kind of kept on hold. The main idea, and if you understand this, you'll understand how those channels work. So let's say you have, can I make this any bigger? I can I? Yeah, great. So as you put in messages into your clicks topic, that message is duplicated into these 3 channels. Then let's say on one of those channels you have 3 consumers, only one of them will receive. So that's kind of the multicast kind of idea. And then as another message goes, it will round robin to a different consumer. There's a few options I think you can use for that, but the default I believe is round robin. So the NSQD know that there's X consumers for this, and we'll just go around them. So the nice thing I suppose as well with the NSQ is that it's written in Go, and I've kind of along with Node, I'd say Go is probably my favorite language. I haven't done anything professionally, I just kind of play it at home. But if you think of, if you know Go and you know the concept of channels, it's pretty much why these guys were able to write this only with a few thousand lines of code, the whole system, because it uses a lot of the concepts of channels in Go and kind of puts them to work for you. So the thing that we haven't really seen on the demo is the whole scaling part, where just go to this NSQ. So you have your on the right side you have your NSQ lookups, which are the discovery daemons. So the producers register the topics to the discovery service, and the consumers go there to discover. So I mean, it's not any new ideas. The thing is that those NSQ lookups, they don't know about each other, so they are independent. And I think here is where a lot of other projects struggle, because you have to have all these leader elections and quorums and yada yada, and the whole thing doesn't. And I mean, NSQ doesn't make huge claims of being completely, you know, Jepsen test kind of. At least I haven't seen any claim like that. It just works. At least has been working fine for a lot of people. Yeah.
How does it work then? If you have 5 NSQT, you have to register to the 5 of them?
No, you can just go to one.
Okay.
But ideally, you want to go to all of them. because then if you're a consumer who goes to a different one, he's not going to learn about the topic on the other one.
Okay.
So they don't communicate. That's the design, at least they decided to go for.
Okay. But if one of them is failing, then my command will fail? Or
Sorry, say again?
if one of them, of this daemon is failing, and what will happen with my messages or my topics?
Well, the messages and the topics, they're all stored on the daemon level.
Yeah.
That's what you're saying. If one of the daemons or the discovery failed.
The discovery.
Okay, so the question is, if one of the discovery daemons failed, no data would be lost. The only problem you might have is when new producers or consumers come online,
Yes.
then they wouldn't be able to reach that discovery service. They wouldn't know about the other ones. But the ones that were connected before, because when they discover the other ones, then they go on, and you see those green arrows. They're the persistent TCP connections. So you could kill the discovery,
Yeah.
and the system wouldn't die. So
Okay.
does that answer the
Like
question?
if I say I have a 5 NS faculty, and I bring up one of the consumer saying that it has to look for this 5 or one of these 5.
No, normally you give it the 5.
Okay. And if one of them is failing, my consumer will be happy by just having 4.
Yeah.
Okay.
Yeah.
So,
So, well, let me just go through his slides. There's a few. This is the idea with the NSQ to NSQ thing we were talking about earlier. These are the guarantees. You'll see all this on their site, but there's also knobs you can do to handle back pressure. So the idea is that consumers tell the producers how many messages they are able to receive. So you can at any point in your code go and say change this to ready to 0, so you'll handle back pressure if you're being under heavy load and you can't handle that load. So you probably see this better. Now we'll probably just go back to my own presentation. Thanks to Matt for letting me show his speaker deck. There's no point in me doing the same thing he did so well. So if you if you have questions, this is the link to the speaker deck we were just seeing, and the GitHub repository for NSQ. If you have more questions, I'll be happy to answer them. Or yeah.
My question is one of the things you mentioned was that you can subscribe for a topic and a channel, and then when that topic doesn't even exist, but when the producer comes in, the client, that consumer will be ready to receive those messages. But one thing I noticed from your demo was that you started the producer, you omitted the first message, which was like the 1, 2, 3, like the long one, and when you started the express thing, and started another consumer, that message was also delivered, although it was passed.
And the reason it probably was that you see that is because I had it running before.
Mm-hmm.
And even though I had stopped all the clients, there's still data on the disk.
Okay.
So there's files that say how many consumers and topics are. So he knew that he had already delivered that 1 to 3 to the tail. I think it was the tail one, but he knew that the other channel hadn't got that message. So that's kind of the offline mode. So just because the consumer wasn't up, he doesn't. It's not like messages are lost. So it was saved.
Okay, so like the pattern is like if it has in memory, it's going to deliver even if it was like times ages ago. Okay.
Yeah.
So good. Okay. So like imagine like if.
But you could say that your high watermark is 1, so everything is saved to disk. But actually, I haven't really played with that, and it seems I saw some message on the Google community group today. There's some issue around that. They have introduced recently the concept of ephemeral topics. So they had ephemeral channels, which were those we saw with NSQ tail, which when there's no consumer, then they don't bother sending messages to that. But now they have created ephemeral topics. So what you do is there's a convention where you put a pound ephemeral after the name of the topic, and by definition it becomes ephemeral. Then you could play around with how many messages you want to have in memory or persisted to disk, and then you could potentially have something where you drop messages in, and if there's nobody consuming, fine. But when a consumer comes up, you won't get all messages. I haven't played around, but I wanted to actually try that.
So, like in a scenario where basically I have to increase horizontal scale my service because I'm having too much traffic, what's going to happen is as soon as I fire off another consumer, that consumer is going to basically be hit by a huge overhead of all the messages that he hasn't saw that are still in memory on the discovery.
No, depends on the way you do it. If that consumer comes on an existing topic, unless there's messages which are marked as not delivered or not processed, they will go. They will go out, right?
So basically, what happened then from the demo is like the tail didn't declare that message as processed, just consumed it. Is that?
No, it did, but it was on its own channel.
Okay.
So the tail, if we go back to the NSQ admin, the tail has its own channel. So this is on a per channel basis as well.
So okay, cool. Thanks.
Yeah.
Well, I think you ended up answering my question, because I was going to ask for how long does a message stay in the queue. So it's until it's delivered on every topic, right?
On every channel.
On every channel.
Unless,
So you do not have any command to remove the message from the queue exclusively?
You could create a consumer that doesn't do anything, just reads messages and marks them as finished if you wanted to have some kind of take the plug out of the sink, don't bother about it. Yeah.
Okay.
Okay. Thank you everybody for taking the time to listen to me. Thank you. Não há pints, né? Este é teu. Este é teu.
É teu.
Então, o que é que achaste do meu nascimento?
Muito fixe. Tipo, segundo entendo, é uma espécie de